Welcome back. Before I start this video, I want you to please share this video to other people, specifically those in chemistry, as I know people are suffering as of right now. And that's all. So let's start this review on states of matter. Now, there are three states of matter. You have solids, liquids, and gases. Liquids and gases are fluids. Solids just vibrate in place. Now, the thing is, there's also a fourth one, plasma, and many more, but you just have to know these three. Now we're going to talk about kinetic molecular theory, which is objects in motion, and specifically we're going to be talking about gases in motion. And gases, you want to learn three things about them. There's a lot of empty space, there's a lot of random motion with elastic collisions, meaning that the actual collisions do not waste any kinetic energy, and kinetic energy is directly related to temperature. Here we have the equation: kinetic energy is equal to 1/2 times mass, usually in kilograms, times the velocity of meters per second. Now, this is directly also related to pressure, as pressure changes with kinetic energy, as pressure increases with kinetic energy as well. Now we're going to talk about properties of gases and liquids. Diffusion is the spread of particles. Effusion is diffusion through a tiny opening. And then we have pressure, which we talked about previously, which is force per unit area, or 1 atm, also equals to 760 millimeters of mercury, or 101.3 kilopascals. And viscosity is the resistance between particles. This is usually in liquids. The higher the viscosity, the slower it flows. And then we have surface tension, which is the attraction of particles on the surface layer. We have adhesion and cohesion. Adhesion is the attraction between two different particles. Cohesion, the same particles. Capillary action is using both in order to push things up like a tube. And in intermolecular forces, those are forces that hold two particles together, not to be confused with intramolecular forces, which are forces such that are for ionic and covalent compounds. And first, you have dispersion force, which is weak force with temperature shift in electron clouds, which are nonpolar. You have dipole to dipole forces, which are oppositely charged areas of polar molecules attracting each other. And then you have hydrogen bonds, which is a type of dipole-dipole attraction between a negative electronegative atoms with already a hydrogen bond to it, and at least one lone pair. And then this wants to go down, so hydrogen bonding being the strongest and dispersion being the weakest force. And solubility, with like particles dissolve like particles, like polar dissolves polar. You want to also know that ionic dissolves in polar solvents, not non-polar solvents. Now, there are 6 phases of matter. You want to know condensation, freezing, sublimation, deposition, melting, and vaporization. Condensation is gas to liquid, freezing, liquid to solid, sublimation, solid to gas, deposition, gas to solid, melting, solid to liquid, vaporization, liquid to gas. Evaporation is vaporization at the surface. Phase, this is a phase diagram. You want to know the triple point where all 3 phases can exist. You could have gas, liquid, or solid. And you have a critical point where liquids cannot exist. Now, for the gas laws, you have you want to remember the volume. What volume is length times width times height, and you want to know what Kelvin is, which is the degrees Celsius plus 273. You want to know Boyle's law, which is an indirect relationship between pressure and volume. So you have pressure 1 volume times volume 1 is equal to pressure 2 times volume 2. You have Charles' law, which is a direct relationship between volume and temperature. So you have volume 1 divided by the temperature 1 is equal to the volume 2 divided by the temperature 2, where T is in the form of Kelvin. And that's all. Thanks for watching. Please subscribe if you haven't already. That way you could keep track of things. I will always post videos 2 days before test. And yeah.